So we have talked about what a horizontal asymptote is and how to find them. Let's go back to our picture of y equals 1 over x to explore the meaning of a vertical asymptote now that we've talked about limits a little bit. So if you notice here, if I were to approach x equals 0 from the right, I'm going to come along the graph here and I'm coming toward x equals 0, and I can think about the numbers I'm plugging in, numbers that are fractions that are a little bit bigger than 0 but are positive. What's going to happen to my y value? I'm going to have the reciprocal of that fraction, and my y values are going to get closer and closer to infinity as I let x come toward 0 from the right. So if my y values are going to grow and grow without bound, I could say that the limit as x approaches 0 from the right is infinity. I could also just say that there is no limit because infinity is not a limited number. So either one would be correct to say. You can see here as I approach x equals 0 from the left, what happens to the y values? They also grow without limit. They happen to be growing toward negative infinity. So I could say the limit as x approaches 0 from the left of 1 over x is negative infinity. And it turns out this behavior, approaching positive infinity or negative infinity, as x approaches some value, some particular value, is what creates a vertical asymptote. So here, this is what you want to write into your notes. F of x has a vertical asymptote at x equals a if one of two things. The limit of the function as x approaches a from the right is positive infinity or negative infinity, or the limit as x approaches that value a from the left is positive infinity or negative infinity. And think about what makes that happen. If you think about the algebra, what gives us our vertical asymptote at x equals 0? It's the fact that 0 is the one number I can't plug in for this denominator without making a divide by 0 problem. So we're going to watch for that. That's going to be our clue. That was your clue all through pre-calculus when you needed to find a vertical asymptote. We're going to check for places that make our denominator 0, and we'll investigate the behavior and watch our functions grow toward positive or negative infinity. So here's an example. You should write in, we've been asked to explore this function. F of x is x squared minus 1 over 2x plus 4. We're looking for a vertical asymptote, and if we find one, we want to describe what happens to the function as I approach that asymptote from the left and as I approach that asymptote from the right. So I'm going to do what I did in pre-calculus. I'm going to factor. This is a rational function, so I'm going to factor the numerator and denominator and first check and see if anything cancels. So here's my factored version. And for this one, it doesn't happen that anything's going to cancel. I don't have any factors that are perfect matches top and bottom. So I'm going to revert to what I know. I'm going to have a vertical asymptote in this function, any place where my denominator is equal to 0. So that's what I've written here is an equation equating the denominator of my rational function to 0. I can solve, and I'm going to conclude that I'm going to have a vertical asymptote at x equals negative 2. That part you already knew how to do from last year. Watch what's next. All right, so now I want to describe the behavior of the function f of x to the left and to the right of this vertical asymptote at x equals negative 2. So I can make a picture, I could graph it on my calculator, there's lots of things I can do. I want to demonstrate one technique that you're going to find very, very helpful throughout the school year. So maybe you've seen it, maybe you haven't seen it. We already know that there's a vertical asymptote at x equals negative 2. So that means I know that as x approaches 0, my function values, my y's, have to either approach positive infinity or negative infinity, or no other options. So all I really have to do is figure out if the y values are positive to the right of x equals negative 2, or if they're negative. The only thing I care about is the sign of the y value, sign of the y value. So here's something I can do. I want you to imagine plugging in, thinking of a number that's just to the right of x equals negative 2. So just to the right of x equals negative 2 means it's a little bit bigger. I'm just going to pick a number here. Think of negative 1.9. Any number that's just to the right of negative 2. Now imagine plugging in this x value in each of the factors in my factored version. Negative 1.9 take away 1 gives a negative value. Negative 1.9 plus 1 gives a negative value. In the denominator, I have this factor of 2. And what if I added negative 1.9 plus 2? And all I cared about was the sign of the answer. Well, 2 is bigger, so the result is going to be a positive number. Now all I have to do is figure out if I multiply a negative times a negative number, divide by 2 times a positive number, is the result going to be positive or negative? Well, a negative times a negative is a positive, divided by 2 is still positive, divided by a positive, still positive. So, I know that for x is bigger than negative 2, or just to the right of negative 2 at least, y values are going to be positive. That means if I'm going toward one of the infinities, it's got to be toward the positive infinity. So I could conclude, in words, f of x must approach positive infinity as x approaches a negative 2 from the right. Let's practice writing this in limit notation. So I would say the limit as x approaches negative 2 from the right of f of x is equal to positive infinity. Now if I want to explore what happens to the function f of x as I approach negative 2 from the left, I'm going to pick a number a little bit to the left of negative 2. So think about maybe negative 2.1. I'm going to have a similar experience when I try to plug in. Remember, I only care about the sign of each factor. Negative 2.1 take away 1 will be negative. Negative 2.1 plus 1 is still negative. 2, and then x plus 2. So negative 2.1 plus 2. This time will give a negative result. I have a negative times a negative divided by a negative. My result will be negative. And since I know I was either approaching negative infinity or positive infinity, I have to conclude that my function approaches negative infinity as x approaches negative 2 from the left. And then in words, or in math symbols, so the limit as x approaches negative 2 from the left of f of x is negative infinity. That's your answer.